So in today's session, we can discuss about the cable sizing. Okay, so how to select a cable, how to size the cable depending upon the connector load and everything. Okay, so let's start with an example. Okay, so calculate the cable size for a 36 kilowatt. Okay, we'll start with a single phase one. With a 3 kilowatt. Let's see. Okay, so calculate the cable size for 3 kilowatt residential load. Okay, so we already know how to calculate the MB rating and the MCB rating. So same like that, we had to calculate what? Yeah, MCB rating. The same way to calculate the maximum demand. That is MD is equal to total connected load divided by diversity factor into power factor. So all these things we all discuss. I'm just going to what? Fast forward this one. So here total connected load will be 3 kilowatt. Okay, and diversity factor again it is 1.5 because it's a residential, so that means it's a variable load. Okay, then power factor it will be 0.8. Okay, then equation will be that is equal to 3 kilowatt here 1.5 diversity factor 0.8. Okay, that means 3 divided by 1.5 into 0.8. Okay, so that means 1.6 kVA, that's a load. Okay, now for this one we have to calculate the ambient rating. Okay, so equation is P is equal to VI. For that I will become I is equal to P divided by P. Okay, so here power is already given, that is what 1.6 kVA. Voltage will be V will be 230 because it's a single phase connection, right? So voltage is 230. Okay, so in that case I that is equal to P 1.6 into 1000, okay, divided by 230. Okay, so 6.95 ampere. Okay, so that's our ampere rating. Okay, 6.9. Okay, you can find out the factor safety also. Next is factor safety. Factor safety is considered a 20 percentage. Okay, so that 6.9 into 1.2, that will be 8.34 ampere. So we already know how to calculate the what MCB rating. Okay, so MCB rating will be depending upon so page number 7, our data book. Here miniature circuit breakers. Okay, from here we have 8.3. Okay, so 8.3 means after 6 ampere, next available MCB rating is 10 ampere. So 10 is the circuit breaker rating. Okay, so we can select that. MCB rating will be 10 ampere. Okay, 10 ampere. Okay, so that's our MCB rating. So once you so up to here we already discussed in the previous classes how to calculate the MCB rating and everything. Up to here it will be same. Okay, how to calculate maximum equation, current rating equation, both will be same till here. And cables we are selecting based on the MCB rating. That is what is our circuit breaker rating. Based on that only we are selecting the cable size. Okay, so here cables are written in a certain format that is called runs by core by millimeter square. Okay. Okay, now this considers as what? Square. Okay, millimeter square. So here runs means that is number of cables. Okay, number of cables means how many number of cables are taken for this connection. Okay, that is runs. Okay, then core we all discussed. That is what single core cable, two core cable, three core cable, 3.5 core, 5 core. This is the core. Okay, so based on the load, we have to choose the core here. Okay, core basically means the number of conductors. That's it. Okay, and we already discussed that for single phase connection, single phase the core will be two core cable. Okay, and for three phase less than. Okay, less than 50 ampere will go for four core cable. Okay, and again three phase above 50 ampere, above 50 ampere will go for 3.5 core cable. Okay, then three phase equipment, three phase equipments will go for three core cable. So this is also selection criteria based on the load and the type. Okay, now finally is the mm square. Mm square is a cross section area of the conductor. Okay, so that is given in millimeter square. So mm square is the cross section. Cross section. So this is how you write the cable format. So in our condition, we have the MCB rating that is 10 ampere. Okay, 10 ampere is given. That means our cable size will be okay, cable size will be okay. Let's come to page number 8. Okay, so in the next page number you can see cable sizes, and here the first column is given the ampere rating 16, 20, 25, 32. This is the ampere rating is given. Okay, and in the next column it is given the size in mm square. That means our cross section area. Okay, size in mm square is given here. Next column run is given, runs in numbers. So this one, two, these are the number of cables taken. Okay, for example, if you consider this cable, this one. Okay, if you are considering this cable, this one is a single core cable. But how many numbers are taken? 1, 2, 3, 4, 5. So 5 runs, single core cable is taken here. Okay, here you can see it's a single cable but having two conductors. So one run, two core cable is taken here. Okay, here it is two number is given. That means two runs, three core cable. Like that it is. Okay, clear? So here 10 ampere. So okay, actually here 10 is not given. So just write down. For 10 ampere, the size will be 10 ampere. Size will be 2.5 mm square. Okay, 2.5 mm square. Runs will be 1 itself. Okay, and you can notice one thing here, core is not given. So core you have to select based on these conditions. Okay, runs, that is one is the runs, then core. So here you can see it's 10 ampere. Okay, also will say single phase load. So single phase connection, what it is? Single phase connection, it is 2 core. So it is 2 core cable. Okay, and what is the cross section area? Cross section area is 2.5. Okay, so you can write down 2.5. So this will be your cable size. Okay, so one run, 2 core cable, 2.5 mm square is the cable size for this condition. Okay, clear? Any doubts? Okay, so I guess this one is okay. The same way, just do one for the three-phase connection. Okay, so for three-phase connection, it will be, let's say, a 25 kilowatt load. Okay, so 25 total connect load will be 25. Okay, diversity factor will be 1.5 and power factor will be what? Okay, power factor will be 0.8 itself, so that it will be 20 kVA. Okay, for 20 kVA, same equation P is equal to VI. Then we have I is equal to P by V, and voltage will be 415 volt. Okay, so that equation will be P is equal to root 3 VI. Okay, so change here. P is equal to root 3 VI. Okay, P by root 3 V. Okay, so that equation will be into 1000 divided by 1.732 into 415. Okay, that will be 28.9 ampere. Considering factors of 20%, it will be 34.78. So that the MCB rating will be 34. After 34, next available is 40 ampere. Okay, so selected MCB rating will be 40 ampere. And based on 40 ampere, come to page number 8. Okay, here you can see 40 ampere is given here. Runs is 1, size is 16 mm square, and core. Okay, core, it's a three-phase connection. So we have 40 ampere, it's a three-phase connection itself, but it is less than 50 ampere. That means it will be a 5-core cable. Sorry, 4-core cable. Okay, so again, 1 runs into 4-core. Okay, 4-core into cross section area is 60. Okay, so it is 60. So this will be the cable size for three-phase connection. If it is more than 40 ampere, you can go for what? More than 50 ampere, you can go for 3.5 core cable. That's it. Okay, so that's our cable sizing calculation. Clear this one? Okay. So moving to the next topic, that is voltage drop calculation. So voltage drop calculation is calculated if you have a cable length of more than 100 meters. Okay, so if you consider a building, you'll be having a HT panel room will be there. From there, we'll be running cables to the building side. Okay, so if it's a big space means you will have to run the cables for a long distance. So in that case, what will happen is, as the distance increases, there is chance of what? Loss. The voltage will drop. Obviously, it will be dropping. So we have to calculate how much voltage is dropping there. Okay. So as per the standards, you can allow maximum of 3% drop. Okay. So if the drop is more than 3%, we have to go for the next cable size. So the idea is, if the cross-section area is more, lesser the resistance or lesser the drop. Okay. If there is no resistance, means we can what? We'll be having lesser drop will be there. If the cross-section area is small, you will be having higher resistance, so that what? Drop will be more. So that's the idea. So once again, if the cable length exceed over 100-meter length, you have to calculate the voltage drop calculation. And after calculation, if the drop is less than what? 3%, you can allow it. Or if the drop is more than 3%, you have to choose the next cable size. Okay, and the equation for that, it is voltage drop in volt is equal to voltage divided by current into rated current in ampere into cable length in meter. Okay, so you can simplify that. That means voltage by current, V by I, is what? Resistance. Okay, so that resistance per meter into rated current into cable length. So this is the equation to find out the voltage drop. Okay, and percentage, as usual, equation, that means voltage drop in volt divided by the total supply voltage into 100. So we'll get the percentage for that. Okay, so let's see one example how to calculate that. Okay, so clear everything here. So one example, that is calculate cable size for 8C7 kVA incoming load for 350 meter length. Okay, so first of all, what is given is, it's given the power is given. That means we have to calculate the ampere rating, also the MCB rating, as well as the cable size also. Okay, so here maximum demand is given 87 kVA, and current rating we have to find out using the equation, that is I is equal to P by root 3V. So once you use that equation, you will get what? The current rating. Here, instead of that, a factor is given. It's called multiplication factor. Okay, so I'll come to that in the next class. What is multiplication factor and how to calculate that. For now, let's understand that instead of using the equation, we are using a one factor. For three-phase connection, the factor is 1.4. Okay, so if you multiply 1.4 into 87, you will get what? 121.8 ampere. So instead of using that I is equal to P by equation, you can what? Use this factor. That's it. Okay. Then again, factor safety 20% is considered here. That is 1.2 into 121.8, you'll get 146.16 ampere. Based on that, you have to calculate the circuit breaker rating. Okay, so here MCCB is considered. In that case, the current rating value will round off and give us the set value. And the factor safety value, we'll check in the table after 146. MCCB is given here. After 146, next available is 160 ampere. Okay, so it will be 160 by 125. That's MCB rate. Okay, and in case of MCCB, cable size is taken based on 160 ampere, because 160 is the maximum current rating or the maximum capacity of that MCB. So the cable selection will be depending upon the switch rating of the MCCB. So that is 160 ampere. So we can go for the table here. 160. Okay, 160 is here. Okay, so here you can see the runs is 1. Cross section area is what? 185. And one more thing here, it's not specified what kind of load it is. It's just giving incoming load it is. So not specified what kind of application it is. Okay, we know it is three phase. So that we have three options here. Okay, that is 3.5 is there, 4 core is there, then 3 core is there. Here it's considered, I have considered a 3 core cable. Okay, so one run, 3 core, and 185 mm square. Okay, so that's the cable size for this condition. Okay, so once you got this value, once you get the cable size, you can what? You can start with the voltage drop calculation. Okay, so first thing, equation once again, we have resistance per meter into rated current into cable length. So in this equation, the values we have right now is the rated current value. Rated current means our current rating. Okay, that is not with the factor safety. Okay, so current rating is 121.8. That is the actual current rating. This is the 20% extra value. Okay, so we have the current rating value. Then we have the cable length, that is 350 meters. So we have both the values. We have to find out the resistance per meter. This value you can get from page number, the same data book itself, page number 11. Okay, so voltage drop and resistance for cables. Okay, here first of all it is given the cross section area of the cable, selected cable. Okay, here our cross section area is okay, 185 mm square. So for 185, okay, 185 is here. Okay, so this is the cross section area. We need is the voltage drop or the resistance of that cable. Okay, so a small mistake here. It's not given in meter. Actually, this is given in kilometers. Okay, so for 185, the value will be 0.37. Okay, 0.37 resistance per kilometer. Okay, not meter. Okay, so kilometers given. Okay, so that we have to convert the value to what? Meter to kilometer to meter. Okay, so in equation when you substitute this to what? Yeah, divide by 1000. So 0.37 divided by 1000 into 121.8 is our rated current. That's our current rating here. Okay, current rating here into length is what? 350 meters. So into 350. So we got 15.77 volt. So that's a drop happening. That means suppose if it's a three-phase it's a three-phase connection, that means you will supply what? Yeah, 415 volt you will supply through this cable. Okay, so this cable length is 350 meter. So 450 on the starting, cable length is 350. When it reaches the end, it will be only 400 volt, because while traveling 350 meter, 15.7 volt will be lost. So you'll only get 400 volt on the end side. So that's what happening here. Okay, so since we got this one, you have to calculate what is the percentage drop happening. Okay, so percentage drop you can calculate another equation, that is voltage drop in volt divided by supply voltage into 100. So voltage drop in volt is 15.7. Supply voltage means supply voltage for this connection, that is three phase. So it will be 415 into 100. Okay, so you'll get 3.8. Okay, so 3.8 as per our condition, we have to go below 3%. So 3.8 is again what? Small. Okay. So that we cannot consider this cable, that is this cable size is not okay for our condition. Okay, this one is not okay for our condition, so we have to go for the next cable size. After 185, next cable size available is, you can check in the table itself. After 185, next is 240 mm square. So we can take one runs, 3 core, 240. So only cross section is changing. Okay, runs will be same. core will be C. Okay, so cross section area will be 240 mm square. So now we have to calculate. Again, it's not finished yet. We have to calculate till we get a value less than 3%. Okay, so 240. So for 240 mm square, we have to calculate what is the drop. Okay, so again, come to the table here. So here it is 3.7. For 240 mm square, it will be 0.3. Same condition applies here. 0.3 divided by 1000. And rated current and length will what? Remain constant. Only the resistance will what? Change based on the cross section area. So 0.3 divided by 1000 into 120 into 350. You get 12.79 volt. Then calculate the percentage here. So what is drop in volt divided by supply voltage into 100, you'll get what? 12.79 divided by 415 into 100, that is 3.08. Like it's okay, 3.08, but still, yeah, we need less than 3. That's it. Okay, so you can go with that one also, no problem. Or you can go for the next one, that is, next size is 300 mm square. Okay, so that next cable size is 1 run, 3 core, and 300 mm square. Similarly, substitute all the values. Resistance per meter, again, for 300 is 0.25. Okay, so point. That calculate the percentage value, that is 10.65 divided by 415 into 100, you'll get 2.56%. So that means, so this is the required value. This is the suggested drop here. We can go less than 3%. So only 10%, 10 volt is what dropping in this case. That means if you supply a 415 watt from one end, at the end you'll receive what? 405. Okay, so after 350 meter cable length, you'll get what? A 405 volt. Only 10 volt is what dropping in this condition. Okay, so that the selected cable size will be 1 run, 3 core, and 300 mm square. So this is the cable size for our example here. Okay, clear. Again, every time you don't have to do that, but if it's a high-rise building, definitely you have to do this equation. Okay. Any doubts? Okay, so by that our cables are over. So next we can move on to the next topic, that is cable trays. Okay, so cable trays, like mentioned before, it's actually what? It's actually a support for the cables. Okay, so in our house, we are using distribution board switches, equipments, everything is we are using. But here the number of cables are less. So we are taking the cables through conduit. So inside the wall, we'll be having a PVC pipe. So that cable conduits are what? Carrying the cable from the distribution board to the switch board to the equipment. So cables are running through the walls. But in the commercial application, we'll be having a lot of cables. N number of cables will be there. So everything we cannot take through what? Yes, through the walls. And we'll be having HT cables will be there. Again, the cross section area will be more. So it's not practically possible to what? Take conduit for every application. So that we have to carry the cables using a support. That support is called cable trace. Okay. So for both are available, that is metallic is available and non-metallic is available. In metallic condition, we'll be having GI, aluminum, stainless steel will be the materials, and in plastic, PVC is the, fiberglass is the, those are the materials for the non-metallic type. Okay, and mainly we are having a 6 type of cable trays. Okay, ladder type cable tray, rough type cable tray, solid bottom, wire mesh, channel type, and single type. So 6 types. Okay, the purpose for every cable tray is to what? Carry the cables and provide support for them. Okay, but it will change depending upon the applications. Okay, so we can start with the first one, that is the ladder type. So this one is a ladder type cable tray. Okay, so ladder type cable trays are used in high tension cable because as the voltage increases or the current rate increases, the temperature will also increase. That means while the current is traveling, it will produce a small amount of heat will be produced by the cables. Okay, so this heat should be dissipated properly. Okay, and in the ladder type, we can see that there are a lot of free space available. Okay, so we are having it's open. Okay, so the cables can what easily dissipate heat to the atmosphere. Okay, so here we'll be having two legs. Okay, then we have this is called rungs. RUNGS. Okay, rungs. Okay, and these are the standard width, depth, and length for the cable trays. And rung spacing means the space between these two legs. There is the rung spacing. Okay, so the standard width, depth, length are actually given actually for what? If you are going for factory made cable trays. If it is site fabricated, we can fabricate based on the requirement in the site. If it is factory made, this is the standard width, depth, and length available, and this is the rung spacing available. Okay. Again, HT cables and high weight, the cable having more weight, for these cables will be carried through ladder type cable tray. Okay. And the second one is tough type cable tray. Rough type, it can use as a intermediate. Okay, it can also carry a ST cable also, and LT cable also you can what carry through the rough type. Okay, and here the ventilation will be moderate because it's not open as what. If you compare with the rough type, it is not open. It's actually closed, but top will be open. Okay, and we have small rungs to what, yeah, for the ventilation purpose. Okay, so also known as perforated cable tray also, both metallic and non-metallic available. If the cable weight is higher, we'll obviously go for what? The metallic one. Okay. And these are the standard width, depth, and length for the rough type. Okay. And the rung spacing will be standard, that is 4 inch will be the rung spacing. Okay. And next is solid bottom. Okay. Again, solid bottom, it's fully covered type of cable tray. So this one is used if you have to take the cable through the outdoor spaces. We'll be using solid bottom. Okay, and here means the heat dissipation will be minimal because it is completely closed. So you cannot take what ST cables and high tension cable through the solid bottom type. Okay, and yeah, these are the standard types, standard size available, length, width, and depth. And we can additionally we can have added that it will provide what EMI and RFI shielding. EMI means electromagnetic interference, and RFI means radio frequency interference. So if this EMI electromagnetic interference comes with our cable, what will happen is the field is distorted. Okay, the current will not flow through the cables properly. So it is having a shielding that will protect from the electromagnetic and radio frequency interference. Okay, and the disadvantage we can say is that since it is completely closed, the moisture will build inside. Okay, so if there is any crack is on the cable and anything, there is chance of what short circuit. So that's a decision we can say for the solid border, but still the purpose is to what completely protect or close the cables. Okay. And next type is wire mesh cable tray. And wire mesh cable tray is actually used to carry lightweight cables. Okay, we don't carry ST cables or LT cables. This one mostly it will be telecommunication and data cables or optic fiber cables will be taken through the wire mesh cable tray. Okay, and both available, metallic and non-metallic is available, and the materials will be steel will be the obvious material, and it will be having a zinc coating. Okay, so whatever you are seeing outside, the white color insulation is actually the zinc coating. Okay, and these are the standard width, depth, and length for the wire mesh cable tray. Okay, and fifth one, that's our channel type cable tray. So this one obviously we have seen here in the household use, also used for channel type cable tray. You can use instead of what our PVC conduit also. But here it will be exposed outside. So conduits will be running inside the wall, so it is not visible most of the time. But here this will be taken through outside the space, and both metallic and non-metallic are available. Okay, so again material PVC and fiberglass, both materials are available. And you can take a lightweight cable, a telecommunication cable, or speaker cables through the channel type. Okay. And the last one is single rail cable tray. Because single rail is actually similar to our ladder type one. So in ladder type, we have two legs and rungs between that. Here we have a single support to the center. Then we have rungs given like this. Okay. So that here you can take both. Like you can take both low voltage cables you can take, and both what ST cables or power cables also you can what take this one. Advantage is it is actually easy to install. That's it. So we don't have a lot of supports for this one. That's it. Okay. Then these are the standard width, depth, and length for the cable trays. Okay. So yes, these are the six type of cable trays and where it is used based on the application. Okay. So doubts. Okay. Now next we can see a small example. How to select cable trays, or how the cable trays are fabricated depending upon the cables we have. Okay. So we already discussed here cable trays having a standard width will be there, depth will be there, and length will be there. Also, the to carry the weight. So these things we have to calculate. Okay. So here for an example, uh, question is given here that calculate the tray size for the following cable schedule. The tray should be perforated and should have a 20% spare capacity. That means we have to add a 20% extra, because in future if you are adding any other cables, it should have the space for that. That's it. And the distance between each cable should be 10 mm, and single cables lying in a single layer. Okay, so 10 mm gap means so there should be a small spacing between the cables, so it should not closely packed. Okay, and single layer means this is single layer. Two layer means we will be having one more cables, yes, over this one. That's a layer type. Okay, so here single layer, 10 mm spacing between each cables, and we should give a 20% spare for all. Okay, and the cable schedules are two number of 3.5 core cable with 300 square mm is a which is having a outer diameter of 59.7 mm. So when you consider the size here, we don't take what the conductor size. We are actually taking the outer diameter size. Okay, and the weight is 5.9 grams per meter. Second number is given two number of 3.5 core 400 mm square cable. This is having a outer diameter of 68.6. 6.1 kilogram per meter. That's it. Then again, third type is 3 number of 3.54 to 25 mm square cable with 28 mm outer diameter and 0.5 gram per meter. Okay, so these are the 3 cables given for the condition. Okay, so nothing, we have to calculate the width, height, and length. Okay, here length is not specified. Length will be depending upon site condition. So first we can calculate what the width and height for this one. So width will be this one. Okay, so how to calculate the width? Just add the outer diameter of the cable, all the cables. Okay, so here we have two 59.7 cable, two 68.6 cables, and three 28 mm cable. Just add all these. So once you add that, you will get the total width of the cable. But one thing is mentioned that you should maintain a 10 mm gap between each cables. So you can add 10 mm spacing. That is 1, 2, 3, 4, 5, 6. So there is 6 spacings are given here. So 6 into 10, total 60 mm will be what? Given as the spacing or the gap between the cables. Okay, even if you want, you can take the spacing from this outer side also. If you want to take 10 mm here, 10 mm here means you'll be having a 80 mm spacing will be between the cables and the outer side. Okay, it's up to you. If you want, you can take that. Okay, and you should add a 20% spare. Okay, so first thing, total width. Just added all the outer diameter of the cable plus 6 into 10, that's spacing between the cables. So we got 400.6 mm. Okay, so got the width, but we have to add the 20% spare. Okay, so that means 400.6 into 1.2, you'll get what? 480.72 mm. Okay, so this is the required width of our cable tray. Okay. Now, total weight of the cable, again, it is already given here. Okay, so just calculate that. 2 into 5.9. So for the first cable, it is 5.9. Second cable is 6.1. Third cable, it is 0.8. So 2 into 5.9 plus 2 into 6.1 plus 3 into 0.8, you will get what? 25.5 kilogram per meter. That's the weight. Again, adding a 20% extra, you will have 30.6 kilogram. Okay. Next is height. Height of the cable, actually we have to choose based on the highest diameter cable. In this cable, the highest diameter is for the second type, that is 68.6. This is having the higher diameter. So the height we can choose based on what? The highest one plus a 20% extra. Okay, so that it will be 68.6 into 1.2, that will be 82.32 millimeter. Okay, so that we got our height, weight, and the width. And the question is, one thing is mentioned here. Here available cable tray sizes are 300 by 100 mm of 120 kilogram per meter capacity. And second type is 600 by 100 mm with 120 same weight capacity. Okay, so first type is 300 by 100. Okay, so you notice one thing, our width is actually 480. That means the first type is again not suitable for this condition. Weight and height is okay. Weight we can go up to 30 kilogram. It is up to 120 is given, and height is 100 mm. So that means we have only 82. So height base and weight base okay, but width is not suitable. And the second type is 600 by 100. So again, width is 400 something. So 600 by 100 is okay. Weight is also fine. So the selected cable tray will be 600 by 100. If you are going for the prefabricated or the factory made cable trays. If you are site fabricated, you can go for what? You can go with the same dimension. Okay, so 480, you can again consider, even if you consider 500 also, you can consider 500. And size will be 82, just round off to what? 85 or 90. So this is how you calculate the cable tray. Just take the width of the cable tray, weight, and length depending upon the conditions. Okay. So that's our cable tray calculation. Clear? So I guess everything is clear since we are having no doubts. Okay.